I just want to welcome all of you on behalf of Euro-BioImaging, Instruct, Eric, Thermo Fisher, and the eRImote project. The eRImote project is the project under which umbrella this workshop today is organized. So I would like to give you a brief introduction before we start. If Rebecca, you could move to the next slide. So the eRImote consortium is a consortium of 8 beneficiaries that will identify strategies and solutions to enable a transition to more remote and digital access to research infrastructure services, and thereby reducing need for physical access, supporting green economy and reducing footprint of our eyes, but also increasing access, inclusiveness, and preparedness for events such as the pandemic, which was pretty much the cause for setting up this project. And the eRImote project has 4 key objectives. It wants to build a foundation of knowledge that is based on existing practices and RI responses to the pandemic, and expanding a new implementation of remote and digital solutions for RI infrastructure access. It wants to compile a public knowledge database, including technology, software, resilience strategies for remote and digital methodology, which will include examples of barriers, bottlenecks, future developments, investments, and user experiences. The project will provide a set of recommendations for RIs to foster further developing remote and digital infrastructure processes across all domains, and to implement first use cases of new remote access methods. And it will reach out beyond the project consortium and engage further RI stakeholders in the development of these solutions and processes. On this slide, you see the 8 partners in the consortium that are representing the 4 S3 roadmap domains: life sciences, environmental sciences, physical sciences, and engineering, and social and cultural sciences. And you can see here that Euro-BioImaging and Instruct are a partner in this consortium. And if we move to the next slide, how does the consortium implement their work plan and achieve the objective? It is strongly based on interactive processes, setting up workshops and expert groups. So one pillar was really the initial setup of workshops to identify challenges and solutions to remote access provision for RIs, and that focused on remote training, remote operations, and governance, policy, funding, and impact. And out of the bottlenecks and challenges identified in these initial workshops, action plan for the expert groups was developed to set up an exchange of experience between participants, and also reaching out to industry to address topics such as how to work with the user, the researcher in remote and virtual access, how to deal with data sharing and data access, how to provide remote training for RI staff and users, how to work with remote instrument control and operations, and how to manage international access and accessibility of RI service. And really, out of the exchange of experience we had among these experts groups, we identified a further gap among specifically our consortium members of Instruct and Euro-BioImaging to address remote operations of electron microscopes in more detail. And this is how we then developed this workshop. And if you move to the to develop this workshop for the different nodes of our 2 research infrastructures. And here you see a brief overview of Euro-BioImaging. So we are the European research infrastructure for biological and biomedical imaging. We are represented in 41 nodes that are based in 18 countries around Europe and the EMBL in Heidelberg. We have more than 190 sites and 120 and more different imaging technologies. And if we move to the next slide, you can see that electron microscopy is a service that is offered by a large number of our nodes and that covers a broad portfolio of electron microscopy techniques, also correlative methods together with light microscopy, 2D and 3D EM techniques. And you can find those at the different nodes listed here. Next slide, please. And we are very happy to partner up for this workshop with Thermo Fisher, who is a member of the Euro-BioImaging Industry Board, which is a platform for cross-collaboration between industry partners that manufacture, produce imaging instruments, tools, and software solutions, and our facilities and node staff to directly exchange on technological developments, on new trends, to jointly participate in these kind of trainings and generally be there as a platform for exchange on eye level between the technical experts. And with this, I hand over to Corinna for a brief introduction of Instruct.
Thank you, Claudia. Yeah, also from Instruct, a warm welcome to this workshop. I'm Corinna Brockhaus, project manager at Instruct ERIC, the research infrastructure for structural biology. And yeah, just give you a quick overview of the services we're offering to the research community. So we offer access to high-end technologies in structural biology. So this ranges from sample preparation to biomolecular analysis to 3D analysis. Yeah, so we also offer a funding contribution towards access costs to researchers that are based in our Instruct members. So these are colored in green on the map on the right. And in most cases, this funding contribution will cover the whole access costs. In addition, we also offer funding support for travel and accommodation or sample shipment costs associated to the research visits. And yeah, apart from access to these high-end technologies, we also offer training opportunities such as workshops, internships, and funding for small-scale R&D projects. And if we go to the next slide, I just wanted to highlight our cryo-EM service since this is an EM workshop today. So we offer cryo-EM services both in person and remotely. So we can divide the whole service in two different stages. So researchers can apply for support in sample preparation for cryo-EM, cryo-CLEM, data collection for both single particle analysis and tomography projects, as well as EM image data processing support. In the last year, so 2023, about 30 to 40% of all Instruct access provision was the cryo-EM service. And already this year, in the first few months of 2024, we saw an increase in demand for EM services. So we expect this number to be even higher for this year and potentially the coming years. And then lastly, on the image, the map on the bottom right, you can see the locations of all the facilities offering this cryo-EM service. And we're very excited that one of them, the facility in Leeds in the UK, is also giving a demonstration in this workshop today. Okay, so the next slide, please. This is a quick overview on the agenda. So we will start with, in the first half of the workshop, focusing on remote operation of SEMs. Then we'll have a short break, and then the second half will focus on remote operation of TEMs, and then in the end we have some time dedicated for Q&A. And with that, I'll hand over to Rebecca Thompson from Thermo Fisher.
Hi everybody, and thank you very much for the introductions. Hopefully everybody can see and hear me okay. Apologies that the slides seem to be loading slightly in a bit of a laggy fashion, but hopefully we'll get through together. So I'm really excited about the webinar today. We've brought together facility communities involved with both Euro-BioImaging and Instruct. So I'm conscious that we've got quite a mixed audience looking at a registration list of people who are here today from across different facilities, different research institutes across Europe. And those who have Thermo Fisher or previously FEI equipment in your labs, and some which don't, some which use TEM and some which use SEM. So we really have a bit of a range here present today. And I'm personally really excited about this topic. I think, as Claudia has outlined in the introduction, remote access to equipment is becoming increasingly important for research institutes, for research facilities, for a variety of reasons, and we can delve into some of those as we go through. But sometimes the tools that are available that make this process more straightforward are not, some of the best practices or things which are happening across different facilities, sometimes we don't have an opportunity to share that best practice. So today's meeting, this is essentially a closed meeting, should we say. We didn't advertise it widely, so only facility staff or people involved with Instruct centres and Euro-BioImaging centres are here. So as we go through, please feel free during the question sessions, get involved. We'd love to hear from you in terms of what you're doing at the moment, and hopefully we'll have some really good discussion at the end. So as Corinna outlined, we're going to kick off the programme with talking about SEM. But before we delve into that, I thought I would start off the programme today talking generally about remote access and why we would want to do that and what we would want to achieve. So I should maybe, before I delve into this, give a little bit of a background to myself. So I joined Thermo Fisher approximately, about a year ago now, actually, a year ago this week, pretty much. But before that, I spent 12 years working within a research facility, within a cryo-EM facility, actually at the University of Leeds, where Yehuda was my colleague, so I'm looking forward to his demo later. And within the facility there, we had three main circumstances, really, where one might look to remotely access your electron microscope. And these are not necessarily in order, but kicking off to support user access. So then there may be circumstances where the users are remote, perhaps they're based at another institution, they've shipped samples to you, and you can use online connectivity or remote access to support screening and data acquisition, but also processing. And that can either be by either just viewing the screen, so somebody on site is still operating the instrument, but they're using the remote access to guide or provide some direction in terms of the data acquisition on the machine, or it can be hands-on, and this is what we're going to see in the demonstrations later on both the TEM and the SEM. And then secondly, of course, we have facility staff remote access. I'm sure most of it, all of us on the call here today work with microscopes. Things, although we hope for the best, we plan for the worst. Things do not always go to plan, and it can be extremely helpful to monitor systems out of hours. Just be able to log in, check something is going okay, for example, and potentially then make some corrections or adjustments to the data acquisition. And then finally, we have service access. So the manufacturer of the instrument or the service provider may be able to log in remotely to troubleshoot the instrument, potentially perform maintenance. And for Thermo Fisher, this happens through a system called Rapid, which we can delve into a bit later for those who are interested. So these are the primary topics that we're really going to be focusing in on today. what tools are available to help support researchers to log into a wide variety of instruments remotely. So before we delve into this topic, I've got to say, having gone through the process of setting up microscopes for remote connectivity, and this is the thing in red at the bottom, one of the primary sets of questions which I had to tackle, and which you may be having to tackle as well, are local to your IT and your IT department and your network configuration. So unfortunately today in the call, we're not going to be able to delve into the nuances of anybody's particular system, although we'd be very happy to talk offline if anybody wants to. But what we hope to do is try and give you a flavour of how this is being done in reality and what this looks like. So in terms of Thermo Fisher instruments, there are a number of connections essentially from the outside world into the instrument. So as I mentioned on the previous slide, our service department can make use of a remote connection called Rapid to log into the instruments. This is managed so that the customer has to authorize access, so it's gated. But what this system does do is provide Thermo Fisher service engineers with the ability to be able to access the system, put it into service mode, potentially troubleshoot, or, for example, update software on the system. And going back to Claudia's point around sustainability, this is fantastic. If we can avoid an engineer's journey, physical journey to site, that can potentially reduce wait time, meaning that we can get to customers faster, but also reduces the carbon cost of delivering that. In terms of user and facility staff access to machines, at the moment, the primary way that, that sites are doing this are through remote desktop viewers, VNC, Team Viewer, and we'll see some examples of this later today. So this essentially is using these standard tools, which are used in lots of different contexts, to log in to essentially the microscope control PCs. But we're going to touch in some of the slides today, although we're not going to go into this in detail, around new web-based interfaces which have now started to come online. So Thermo Fisher is able to offer Web UI, which is the latest essentially web interface, and this is only offered at the moment on the Arctis dual beam system, FibSem system, that I think is a really exciting direction of travel in terms of remote access. So diving into a little bit of the detail around SEM and dual beams, in just a few minutes we're going to be getting a hands-on demo from Ingo, who is actually sat right next to me. So I'm calling him today from Eindhoven, and we're really fortunate. Ingo's actually been able to get hold of a system which is based in Munich. So for this demonstration, we're going to have the operator in the Netherlands, in Eindhoven, and the system in Germany, in Munich. So I'm really excited to show you, and I've got to say we haven't planned anything. So for this demo, it's really going to be a case of logging in and live operating the system. So hopefully it's going to give you a really accurate flavour of a very real world application. So I'm not going to delve too much into the detail, but I wanted to give you a flavour of some of the software tools which are available, which make logging in remotely worthwhile as a user or as a facility staff member. So remote access is supported on all of the SEMs offered in Thermo Fisher's portfolio. So this ranges from the Axia, the Prisma, the Quattro, the APREO, which is going to be the system we log in remotely to today, and also the Verios. And also the dual beam systems. So again, there are 3 products currently offered in the life sciences in this space. And these are the Equilos, the gallium fib, and then we have 2 plasma fibs, the Hydra and the Arctis. So many of the software, although every system is different, many of the concepts that we're going to be talking about are applicable across this range of systems. So the thing which really, if we're going to be logging in remotely, one of the things which really makes this work, and hopefully we'll get to see in real life, is essentially boils down to the reliability and the robustness of the auto functions. So I'm just going to play a video here of some auto functions which are running. So we've just seen, so also brightness and contrast running, and then we have an autofocus running. This was recorded by my colleague Tillman, who's on the call today, so he'll be able to answer any more in-depth questions. And you can see on the bottom left, the program is now running through a whole series of alignments on this system, and all of this has been done in a completely hands-off manner. So, and we can see at the end a really lovely, crisp image was collected, and I'm just going to pause on that final image. So what I think is really lovely about this auto function system is that the default settings for the majority of samples tend to work really quite nicely. So if you have a fairly novice user who's coming in, they can use this auto function system either sat at the microscope but also remotely to be able to run through these alignments and get a really lovely, beautiful, crisp image out the other side. And of course, as an expert user, if you want to then go in and tweak these around the edges, you retain that flexibility. So hopefully we'll give you a flavour of some of these auto functions during the demo. And the second element that I really wanted, to highlight in terms of the software is the array tomography. So for those of you who are unaware of array tomography, essentially what we have is a series of serial sections, and the software, in this case MAPS, can be used to automatically, in a few clicks of the button, identify sections. So right at the beginning of this video, you get an idea. We can see the sections lined up there, but maybe this image is a little bit, or this video is a little bit more informative. So in just really a few clicks, we can go through, identify where one section is present, and then the software can, in just 30 to 60 seconds time, in a really reliable and robust manner, then identify all of the rest of the sections. So I think what this really illustrates in terms of a workflow is that the software here, if you were operating this remotely, is robust enough, it's well behaved enough, and it's automated enough that you can be sat, maybe even you don't have the best internet connection in the whole world, and you would be able to, in really a very small number of clicks, set up an entire experiment. So in this case, it would be identifying serial sections from which to take montages. And then once you've taken identified these sections, you can set up an experiment, for example, that runs overnight or runs over a large number of hours and collects montages on all of these sections. And of course, I couldn't finish talking about array tomography without showing you some lovely results. So this is an array tomography result from C. elegans. And so we can see this in this whole workflow, we had some serial sections which were automatically identified, the images then collated, the movie right at the beginning, which I'm just going to skip back to, just shows the stitched images, and there's been no additional on the way. Sorry, it's a very fast video. So on the way down, there has been no alignment of the images, and we can see actually it's still pretty good. And then as the video changes direction, the images have been stitched, and then we finish off with a lovely segmentation where we can look at the volume of this biological specimen. So just adding a little bit more detail on that, really in MAPS to set up this kind of experiment, Tillman did an experiment where he saw how many clicks this was going to take, and the whole workflow could be conducted, or the whole setup of finding the ribbons and then setting up the acquisition could be done in about 50 clicks, which, if we think about how many clicks we do in a day, is really fairly streamlined. So I just wanted to finish off this section of the presentation by just, although Web UI is currently only offered on the ArcTIS dual beam system, I wanted to discuss this because essentially it is a web page which would be accessible to users anywhere with an internet connection. So I said right at the top, many of the remote access criteria are sometimes can be very highly dependent on your local IT, for example. Web UI and then requires you to have a remote desktop viewer of some sorts installed on your computer, whereas Web UI means that any user with a browser can be given potential access to log in and run the experiment, look at the existing results and use that to guide what the next steps are. I was at a course in Martin's Reed last week, and somebody called this software the Instagram of fib milling, which I thought was a really lovely analogy. And I'm really excited about this application because this Web UI essentially brings together what might be present on 3 or 4 different applications into one really simple to use interface. That can also be used offline as well, which means that the system can actually be utilised to collect data 100% of the time, which I think is also really exciting. So hopefully what I've done in that first half of the presentation is give you a little bit of an overview and a flavour of some of the software tools which are available. So what I'd like to do now is stop sharing, and I'm going to hand over to Ingo, who's hopefully going to elaborate much more on some of these themes. So over to you, Ingo.
Thank you very much. So my name is Ingo Gessmann. I'm the, I hope I'm sharing the correct monitor. Yeah. I'm the application manager for cell biology here in the applications lab in Eindhoven. And I was originally planning to show you our Quattro SEM just because it's easy to access. But then it dawned on me that it's probably boring if I remotely control a tool that is located in the same building. Everybody can do that. So having Marina Hesse on site in Munich behind our VolumeScope, I thought that's a much more convincing demo if I remotely control the VolumeScope in Munich and share what I see in a live stream via Teams. So we have gone very far with our remote operation, and we started really early with remotely operating tools because it's for mutual benefit. Customers benefit from greater flexibility. So I give you an example. Last year I was asked to quickly hop on a plane to fly to Australia, which is obviously not so quickly. So it's a 20-hour flight, and then for a 2-day training, that's a lot of extra effort. So and also in the past, if a customer had a problem on his tool, he would give me a call on my mobile phone, and then I had to envision what the problem is, what the UI looks like, and it was almost like in one of these airport disaster movies from the 80s, where the pilot is sick and you ask the customer, can you see the button on your left-hand side, push it. And so nowadays, but we had a big problem. So we started implementing remote operation maybe 15, 20 years ago already for our service people, but customers did not accept it very well. They were suspicious that people can access their tool, and that has changed since the pandemic. When the pandemic started, everybody had restrictions entering his building, number of people that could come, trainings had to be postponed because we couldn't get a hotel on site. And so since the pandemic, remote is widely accepted in our customer install base, and we can use it much more than ever before. And so that's at least one good benefit from the pandemic. I will now connect to our VS in Munich. I hope you can see my screen. I'm connected already. As Rebecca mentioned, there are several ways of connecting and controlling a tool. I would say I have 2 use cases. I would either operate the tool remotely, or I would just share my screens with the customer, for instance, for educational purposes. So if I demonstrate a tool, there's no need for the customer to access the buttons, then I just share the screen. It's also in an academic, in a university environment, it's quite handy. In principle, you can log into your tool with your laptop and show what's going on a TEM, on any tool remotely. And you don't need a lot of extra software or extra effort for it. So I'm now maximizing it. And if you look at my screen, I'm now literally sitting in front of a microscope UI. It doesn't look any different from it would be looking like when I was in Munich operating the tool. And yes, this is really live, so let us have a look. So here we have a live view inside the chamber, and you see the microtome. Here we can see the knife. This is the microtome device we have mounted to the stage. And we have 3 quadrants where we can do things. Just for those of you who are not familiar with our UI, we have these pages on the right-hand side where we can control the different aspects. And also, this UI is highly customizable, and I will customize it now for Marina, so I can just say customize, and then I can add and remove buttons here. For instance, I don't want this. I can move them around. I can reposition them. I can pull pages. Okay. And if I made a big mess, and that's also where we always have default settings for all of our software parts, I can just say these reset to defaults, and you have the default layout of the UI deck. So highly customizable, easy to use, and you can see I can fully operate the tool without a problem. So having said this, what you see here is a piece of grain. It's our reference sample embedded in a resin. And here we have what we call scanning presets.
Yeah, it's 3 o'clock.
Okay, good. Yeah. So let's get a live image. So we have presets here for the scanning, and we also have presets for the column settings, which is very important if you work remotely, because you can concentrate, so to say, all settings on a single button, and you can simply click on it. So here you already see a live image. I hope the update is good enough. Slightly out of focus, so I'm manually refocusing it now. And it's a little whitish, so I just use the auto function, which is F9. So auto contrast brightness done. I can also go to a faster scan speed, but that is probably not so good for the live stream. We all have different speeds here. So let's have a look at the microtome. I can set up a cutting job remotely without the need for me to be behind the tool. And we do this quite a bit. For instance, we do this quite a bit if we have jobs running here in the nanoport. We log in after hours and just have a look if everything is still working. So I'm now on the microtome page for the VolumeScope, and we have set the number of slices to 50. That is mainly for approaching the sample. I'm going to cut with a slice thickness of 100 nanometer, and my cutting speed will be 0.8 millimeter per second. And after 5 cuts, I will take an image, and I will show you how we can identify that we are cutting already. So I unforce the camera and I just say start slicing. And now you can see how the microtome moves into the pre-cut position. And then it takes a slice off on the way back. It will now do it 5 times. Yeah, I think we are cutting already. So Marina did a nice job setting it up, but I want to polish the sample surface a little more. So I let it continue. It will take another 5 sections. So another 500 nanometers off. And then it will require another preview image. And then I will stop it here and move over to maps. And I will set up a simple serial block phase imaging job, fully remote, with the live stream shared from Eindhoven, operating a tool in Munich. Okay, so we can clearly see we are cutting. The landscape has changed quite a bit. And I will now try to be smart. It's not easy for me, and I'll take an overview image first. So I will take an image of the entire block face. Something like this. So you see the area I'm cutting is roughly 400 by 400 micron. And once I've taken this overview image, I will move over to Maps. Maps is the software that is in the center of all of our life science applications. We can run it on TEMs as well as on SEMs. It's very suitable for remote operation because de facto it's an optical way of setting up a macro, and then it will acquire a number of images for you without the need to get involved yourself anymore. So I will now just create what we call a layer, and I will call it Roadshow. And make this first layer invisible. And I'm now gonna import the image I've just taken into Maps. So this image is now for navigational purposes. Okay, so there are different ways of operating maps. There's a TEM way and there's a correct way, the SEM way of operating maps. It's now set to TEM operator, so I'm going to quickly change the settings. And I will go to classic maps, apply, okay. So now this is my maps again. I can zoom in and out, I can pen, and I can simply say add tiles here. I zoom in a little more and I find a nice area. Let's take something with a cell body. That's, oh yeah, there is a cell body. It's always interesting. And I go to energy setup. And I'm going to use 1 energy, I'm going to use 2 kV. And I can now send this to my SEM. And I can make it live. And we have sort of an image. So at 2 kV, I don't need to do much. However, as Rebecca mentioned, the auto functions, I will show you that we have auto everything. So we go to auto functions. And as you see, I'm configuring it, and it almost feels like I'm behind the tool. Only the image update is a little slow, but I think that's fine. So for each of these auto functions, I can as well also just push a button. It's too bad I can only share 1 monitor, so it's very difficult to stream 2 monitors at the same time. So I have to be quick. I'm going to run autofocus now by just clicking the play button, and then I have to quickly switch to XTUI. And you see at the upper part of the screen, we are running autofocus. And I think it did a pretty good job focusing my image. So focus, of course, is not enough. And I see that my sample starts charging. So I will decrease my current to 50 picoamps. That looks a whole lot better. And I'll go back to maps, and now I make my life easy. I just align my my image, so it's now doing everything: focus, stigmata centering, you name it. It's auto everything. So it's simply aligning the complete tool without me doing any hands-on. So if you have any questions, feel free to put them in the chat. I'm happy to answer them. At the moment, I'm just sitting here waiting for the auto functions to do the work for me. At the moment, it's doing the stigmata alignment.
Ingo, while the auto functions are running in the background, I was wondering if you could comment on, in the real world, when you're running systems remotely, which you do every day, is there anything that facilities would need to be wary of or cautious of? Are there any operations which either can't or you would recommend should not be done remotely?
Well, the biggest problem with remote operation is you have to get a sample in and out. So that's fantastic on our Krios. We have a cassette with multiple samples, and we can load multiple samples. And in the case of the volumes also, there are steps that can't be conducted remotely. For instance, putting a sample in a microtome and doing the first approach in air, that cannot be done remotely unless you get some dedicated robotic arms and other automation. But other than that, our biggest obstacle typically are the IT departments. They are very reluctant to make their users' life easier. But I can assure you, what we are doing here is perfectly safe. For instance, on SEM, by definition, we always have 2 PCs. We have a microscope PC, which is never directly connected to the internet. And we have a support PC that is connected to the internet. and to get to the microscope PC, you always have to go through the support PC, which adds an additional layer of safety. And with our Rapid server, you have to give us a password so we can enter your tool. So unless you actively decide to give us free access, it is literally impossible to just hack into your tool and do stuff with it. Yeah. So it always needs a customer to agree or to set it up in a way that it can be approached at all times. And I've mentioned, it looks like it's ready. Is that possible? That's so fast. Indeed. So auto functions have finished. You see, it was really fast. And yeah, what you can see here is a focused image, and it was pretty much effortless. So I will now set up. I will set up a run. Here we can check. So it's a super critical software, as you can see. It's not happy with the lens align. So let's see what the lens align looks like manually. But as I said, it's super. It's a little, yeah, lens align is good. There's no problem with lens alignment.
Yeah, so I think that really nicely illustrates how in the software it's very straightforward to see in the software flags if there is something to get of concern. So especially when there are maybe less experienced users using the system, they can they know when they might need to flag something or where something might need an additional investigation.
Yeah, absolutely. And what I always say, it's so easy to use that even I can operate it, and I'm just a manager. Yeah. So so let's see. I think I should set up a run now. So let's see, we have a tile set, we have an aligned energy stack. We go to auto functions. We now run the initial auto functions. And then we have the ones we call live. And so the system is super stable. So in principle, I don't need to run auto functions all the time. I will run a few of them for demonstration purposes. Yeah. People always ask me, do you have to align every tile set? No, you don't. You can, the alignments are there, but when I'm demonstrating it, I'm aligning it so people see how that it works and how fast it works. And yeah, let's run contrast brightness. It's always good. And let's run a focus. You run the final focus. And we do the fine position alignment. Okay. So now I go back to XT UI to give, and because I've exposed the surface, I will do a few more cuts. Let's say I take 300 nanometers off, so I do 3 cuts, this time without taking images in between. So I unpause it. And I must say, it's amazing. It almost feels like I'm sitting behind the VolumeScope. So I haven't done this in a while. I can just operate it. And this is it. So it's almost boring, and that's boring is always best, I would say. The only thing I'm missing in this type of event is live interaction with the audience. But please, if you have questions, type it into the chat, even though I'm more like a talker and not so much a writer, but okay. So here we have a job manager. different jobs are queued up. And I actually only want to run the one I've just done. So I've unchecked the other jobs that I don't want to run. We have just configured auto functions. Let's cut 50 nanometers. 50 nanometers always work. And let's do something like 20 slices. Because we have 6 minutes left. And one more thing to check. I didn't check my scan speed, so I go to basic. One by one, this is my horizontal field widths. I'm going to use 1 microsecond. And I will acquire only 1 frame, so that's fine. You can preset more things. You can see here the overlap if you should be tiling. You can define it in percent or in pixel. Beam current you can automatically attach to a tile set, so you can acquire tile sets with different currents and different acceleration voltages within the same cut. You can define the detector you want to, you name it, you can define it somewhere here. You can also define processing. So we have 2 PCs, and it's not only for internet security, but on the support PC we have 2 GPUs, and 1 GPU we exclusively use for processing while we are acquiring an image stack. That makes it very convenient and very fast. So and it will also automatically do a stack alignment. So for now I set it to translation. We should be all good, and then all I need to do. Slicing velocity is a little high. It should be 0.1 millimeter per second. And then we run. And this is it. So I'm done. I'm out of it. Job is running.
So in this next part of the webinar, we're going to focus really in on transmission electron microscopes. And as we said in the introduction, really grateful and delighted that Yehuda from the University of Leeds, the APREO Biostructure Laboratory, can join us and do a demonstration of their remote access to their Titan Krios instruments. But before we delve into Yehuda's demonstration, I thought I'd provide a little bit again of kind of background and contexts. So remote access is available again on the entire portfolio of transmission electron microscopes in the Thermo Fisher portfolio. And I guess I really wanted to point this out for TEM because I think looking at the survey, the majority of you who look after facilities with what we would call the higher end cryo electron microscopes, you know, the Titan Krios and the Glacios, almost all facilities have remote access set up for at least their facility staff to be logging in and maybe doing some data setup or troubleshooting. But almost nobody has got their entry-level tools or their lower KV tools set up for remote access, except maybe for service to log in. But remote access is available across this portfolio, and basically all of the softwares that I'm going to talk about today, which really facilitate remote data acquisition on the instruments and make that process nice and easy for the user, are available across this suite of tools. And where there are some special softwares available, I'll point those out as we go. So the majority at the moment of cryo-electron microscopy usage in the life sciences is single particle data acquisition for high resolution structural biology. I think it was really interesting to see that Instruct are currently offering about 30 to 40% of their access provision to cryo-electron microscopy. And Corinna can probably confirm later, but I suspect the vast majority of that is single particle at the moment, single particle cryo-electron microscopy. And in terms of the Thermo Fisher ecosystem, the piece of software that we use to drive single particle data acquisition is called EPU. So EPU, forgive my Latin, stands for E Pluribus Unum, which some of you may recognize as the motto of the United States of America. But in its translation is out of many, one. So the idea being out of many particles, we generate one average or one structure. Of course, actually, in many data collections these days, we produce more than one structure. But anyway, I like the story behind it. So the EPU software is really the thing which allows us to drive this data acquisition in a really automated manner. And recently, Thermo Fisher has released Smart EPU, which brings together not only the image acquisition, the data acquisition itself, but also on-the-fly processing options, which I'll talk through a little bit, and then plugging that data into algorithms which can then be fed back into the data acquisition. I think this is a really exciting direction of travel that we can discuss more in detail. But I want to kind of start at the beginning and walk you through what kind of tools are available in the software and what this looks like. So broadly, we'll talk through kind of the sessions, setting up, getting to the microscope. What does this look like? Screening and setting up the data acquisition. Then we'll run through processing on the fly, and then I couldn't give this webinar without speaking about tomography at the end, because we're finding that there's a significant growth of interest in collecting tilt series data. So I'll talk a little bit about what's available in that space. Okay, so starting at the top. In terms of EPU, as a program, it's designed to make life as easy as possible for the user. And everybody on this call is what I would probably call expert users. You're running facilities, you're running research infrastructures. So maybe if you're the experts. But most of the people, or many of the people that you work with, might be coming to microscopy for the first time. They might be using many different techniques as part of their projects. So really the goal of EPU is to try and make something which is really quite easy to access and easy to pick up and become trained on. We typically find that training novice users on EPU to be able to set up a session takes no more than a couple of hours, thanks to the features which I'm going to talk through. So within Smart EPU, you as a technique expert or as a facility manager or somebody running a research infrastructure can set up preset experiments, for example, which you can have available for your users to preload. Secondly, there's a traffic light system. And this traffic light system basically says immediately, is everything okay? Is something not okay, i.e. do I need to go and ask for help? This is something that we saw a little bit with the SEM as well, and I think we find that having it really clearly displayed in this way makes it super straightforward, even for people new to the technique. And of course, if there is something wrong, this means that you can then go and stage a bit of an intervention. And then just to build on a little bit on some of the detail. So when I said you can preload some experiment types, you within the facility, or you can use defaults, can set these recipes, a high resolution data acquisition, maybe a medium resolution, so maybe slightly lower magnification, you're not reaching for the stars in terms of the results, and maybe a quick recipe just for screening, just to see what things look like. So this can make it very, very easy for somebody coming to this for the first time, and of course can all be done at the microscope, but also entirely remotely. So sorry, I skipped over. So I'm just rearranging my screen. So throughout this process, there are the workflow is pretty obvious, and the user is guided through. And pretty much at every stage, the software can make recommendations, or in some cases even take over from the operator to perform particular functions. Of course, not everything can or should be done by the user. So I wanted to take this opportunity to point out that in the back end of, so one of the things you can do as an expert user of the instrument, you can load the virtual hand panels. So literally the hand panels that you're used to physically having in front of you, all of that functionality is available through this GUI interface. So there is nothing that you, well, it basically means that there is nothing that you can't do remotely that you couldn't do sat at the instrument. The only exception I would say to that is there are some things where, you're going back to the question earlier on buffering, sometimes you need very, very live feedback in terms of what the image is doing for certain alignments, and they would be very tricky to do remotely. But basically 99.9% of everything you would want to do can be done remotely through the combination of the software and, if needed for additional functions, the hand panels. What we're going to see in Yehuda's live demonstration is remote access into a Titan Krios instrument. So this will have two screens. There will be one with the TEM user interface and one with EPU. But the one and that is basically available on all of the TEM portfolio. But the one exception to this is the Tundra instrument. So the Tundra instrument is a 100 kV system, which is really optimized for single particle cryo electron microscopy. And this has gone really one step further in terms of simplifying, bringing everything together in a really automated manner, and also crucially for remote access, it brings everything together on one screen. So although this isn't going to be the focus of our webinar today, I really just wanted to point out, in a similar way to we discussed WebUI in the SEM section, this interface is available on the Tundra system. Okay, so you've sat at your microscope from wherever you are in the world, and you've checked the microscope, everything's kind of looking good, and you're now going to proceed to set up your data acquisition. So using EPU3, this is really easy to do. As I mentioned before, this software can be installed on any instrument, from a Talos up to a Krios. And the really nice thing sometimes about installing EPU on a Talos, for example, and maybe even collecting negative stain data using this, is if you have this software installed on all of your instruments, it familiarizes the users to the workflows early on in their electron microscopy journey, and that can save, as a facility, can save you quite a lot of time in terms of training and troubleshooting. So the idea is with EPU, and specifically EPU3, is it provides this workflow which you're guided through, and you can set up a data acquisition on your grid, certainly in less than 30 minutes. I'd love to hear in the chat maybe how long you feel it takes you to set up an average EPU session. Maybe a range is more appropriate, because obviously some projects are trickier and some projects are easier, but it's certainly possible in a very short amount of time to set up a single data acquisition on a single grid. But of course, one of the primary benefits with a Titan Krios instrument or a Glacios instrument is that we don't just load one sample, one grid, into our transmission electron microscope at the same time, and we can load up to 12 grids into our autoloader, and using a EPU multi-grid, this is a piece of software which allows you really in just a couple of clicks to set up an entire experiments for every single grid in the cassette. So this is really cool, because you could literally load 12 grids into your cassette, into your instrument, with just a couple of clicks. Say, okay, I want to collect a half-an-hour data set on each of these grid positions, and then you just press go, and the microscope then will go away and collect that data for you. And you can of course set up different recipes, different acquisition parameters on each of these samples. You don't have to screen all of the grids, so it can be really very flexible. But at its heart, it makes it very easy for you to screen through all of the samples that are loaded in your instrument at the same time. So I think this is really cool. And I certainly found that it was very useful in terms of improving the efficiency of the Krios instruments. So I'm not going to, this is just kind of a screenshot of what this looks like in real life. I'm not going to go into this into too much detail because I suspect Yehuda will probably show the screen during his demo. But I wanted to show you a bit of a real life example of what this looks like. So this is a case study where the researchers were binding the COVID spike protein to a Fab fragment, so and a small antibody fragment. And they had 12 grids, obviously 12 different antibodies, essentially, or 12 different Fabs. And they were able in one single microscope session to generate 12 sub-3 angstrom reconstructions of these complexes. So when we talk about structural techniques, quite often we will talk about X-ray crystallography, for example, as having the ability to be very high throughput. And whilst I still would not make such a claim for electron microscopy, I would still not say that we're at a position that it's a high throughput technique. It's certainly become much more high throughput in the last couple of years compared to a decade previously, for example. It's now very, very possible to be generating 24 structures a day for well-optimized projects on Titan Krios microscopes, which I think is an incredible position for us to be in. Of course, one of the challenges with us collecting a large amount of data is then processing that data. And if we were to take the data that the microscope was collecting, put that onto a hard disk, walk across our building, plug the hard disk in, download the data, and then start processing the data, it could be days or even weeks before we then have a chance to process that data. And at that moment, we might realize that there was something unexpected. Potentially there was an error with the setup of the data acquisition and some parameters were out of bounds. Potentially the biology was different to what we expected. So, maybe the complex didn't have an antibody bound, for example. So one of the really key things, especially when we're operating instruments remotely, I think, that we can make use of, especially in structural biology and cryo-EM, is on-the-fly processing. So getting a visual whilst you're collecting the data as to what's happening. So when you purchase a Falcon 4i direct electron detector, you have an option to have that. You have an option to have that storage server delivered with a GPU on board. And this allows you to run what's called EPU quality monitor, which allows you to analyze and visualize on the fly the results or some of the initial parameters associated with your data collection. So EPU quality monitor focuses on motion correction and CTF estimation. And this will give you some metrics so that you can check that, for example, the data acquisition is going well. And crucially, if something is out of range, it then gives you the option to feed that back to the microscope and either correct or, for example, to terminate the data acquisition. But of course, this only gives us micrograph level information. It only tells us about the motion and about the CTF estimation of our micrographs. It doesn't tell us anything about our biological specimen of interest, our macromolecules of interest. So this is where on-the-fly processing comes in, and there are many different implementations of pipelines present in different research facilities. But CryoSpark is becoming an increasingly, or potentially probably the predominant software now for processing of single particle data. And Thermo Fisher is able to offer embedded CryoSpark. So this is a version of, this is essentially exactly the same version of CryoSpark, but it's fully embedded into the smart EPU software. So what this means that we can do is the data moves onto the offload server, and we're not just doing motion correction, CTF estimation. We can also do particle picking and potentially 2D classification and eventually 3D classification, for example. And all of that is done on board the offload server. Although, of course, how quickly that keeps up with real time depends on how much data is being acquired, all of these kinds of things. So I would say it's still most common to offload the data onto a more powerful computing system for most of the 3D processing. But this can give us really, really valuable information on the fly about our specimen that we can then feed back into the microscope live, which again I think is a very useful tool in terms of improving the efficiency of Krios data acquisition. So in the last couple of minutes, I just really wanted to highlight some of the software available around cryo-electron tomography. So TOMO5 is Thermo Fisher's offer in terms of tilt series acquisition software. Sorry, it's super dry in here. I've got a tickly throat. And TOMO5, again, really the aim of this software is to allow you to collect quality data, but also for this to be straightforward for new users to pick up. So within the workflow, it allows you to go from really start to finish. So starting off right at the top with your low magnification grid mapping, selection of your areas, and then collection of your search maps. And then right at the end, selection of where your data or your tilt series will be collected. And again, similar to single particle data, this can also be processed on the fly to give you real-time feedback. And I think that this is crucially important and really exciting in single particle data. But I think you could even make the argument it becomes even more important in tomography data acquisition to have this very, very fast feedback in terms of your tilt series acquisition reconstructed into tomograms. Particularly when users are working with lamella data, for example, I think it just helps provide that confidence on the fly that everything is looking good. So what I've essentially run through is a series of softwares which are offered across the transmission electron microscopy range. And although all of these softwares are exactly the same as you would use if you were sat at the instrument, the thing I wanted to stress with this is that because the auto functions are very robust, the workflows are nice and easy to follow, and the software is everything the user needs essentially is within the single screen, is within EPU. It becomes very, very friendly for anybody looking to set this up in a remote access or use the instruments remotely. So before I hand over to Yehuda, let me just check if I did put the agenda slide next. So before I hand over to Yehuda for the fun bit, which is for you to actually see this live, I guess I wanted to just acknowledge the fact that I think that almost everybody who is running electron microscopy facilities has some kind of remote access running at the moment. So it's not all. I think it was about 80% that are on the call today, but the majority do already have remote access. I've got to say, so when I was with the facility in Leeds prior to COVID, we had it set up for the facility. I was super nervous about the potential of letting somebody log into the instrument remotely, particularly, you know, a standard user who maybe is still developing their own learning about the systems. But when COVID came along and we continued our operations, but we couldn't have people traveling to site, we had no choice but to remove this operation online. And I have to say that my experience with that was incredibly positive. Actually, there are many options in terms of limiting, for example, what the users can interact with. That can, as somebody who's looking after the equipment, it can make you more comfortable and ultimately mitigate and minimize any risk of somebody doing something that they shouldn't have done to the instrument while they're remote. There are lots of safety mechanisms within the software, within the microscopes itself, which really do make this something which has the potential to be adopted very, very commonly. So I'm really excited to hear from Yehuda around how they are currently using remote access. So over to you.
So we have two cryoses. That's an official picture of us from a facility. It's in the Wikipedia for some reason, but yay. And like Becky said before, the microscope itself is connected to the microscope computer, which controls the microscope everything, the TEM and the EPU tomography, EPU-D, Serialium, whatever software you install on it, this you install on this computer, and it will control the microscope itself. But because it controls the microscope itself, we don't want to have direct access to the network. So this computer is not even connected to our university network. It's completely isolated. The only thing it's connected to is the support PC. And that support PC is connected to that computer, but it still has layers of protection. So you can see files on it. You can control the microscope computer, but you cannot put files from the support PC into the microscope PC unless you log in with a specific user, and then when you have a specific folder that is again password protected, and you have to go into this, and then you can put files on it. So it's very complicated. It's very hard for someone externally to do it. The easiest way to do it is from someone from Thermo Fisher to come here. They have a special fob they can connect to the microscope computer, and then they get access to it. It's very easy for them to do it. So through the support PC, this is how we give control to external users. How we do it is mostly through wireless. The computer is connected to the network of the university, so it's connected to the internet of the university, so we can have access remotely using any kind of remote access available. Becky said before, we can do rapid for engineers from Thermo Fisher, and every time they log in, we have to give them the IP address, all the codes and numbers we see on the screen, and the password for that microscope specifically. So they cannot just click on a button and log in. It has to be on our side to activate the rapid connection. Another way we can do it is what we use for our users in the university, including us as the facility, and users that have been trained and have their own Leeds IT account, is Microsoft Remote Desktop, which is the software. It lets me control the microscope. I'm actually in the control room, looking both my screens of the microscope because I wanted to do it like Ingo, do it from a different place, like my house or something. But last week we had a phishing attack in the university, so a lot of the IT stuff crashed. So luckily we can do this now. I was a bit worried, but we can do it. So, but I didn't want to risk it, so I'm in the facility itself doing it. And I can control, you can see the mouse move on the microscope itself. I can go to the EPU session, look at different grids. If you have a mouse with a scroll wheel, you can zoom in and out and look at the grids themselves, how they look. Some of them looks better, some of them, you know, they're good. This is what we offer our users because they have IT user account in the university. So it's more protected. They have to access to it to either be on site or use a VPN in order to log into that VPN. So it's more secure. And another way we can do it is through TeamViewer. You can see here on the right side of the screen that I'm logged in also to TeamViewer, and I want to show you this window because this is how we usually give access to remote users. Like from different universities, or if we're doing a workshop, remote workshops, we're doing several in a year, and we need to give access to the user so they can control the microscope. Each session on the TeamViewer is password protected, so you have to give them the password for that session, and with a click of a button, I can change the password and everybody will be disconnected. And when they log in, I can see their username and their account number in TeamViewer. So if they do something fishy, I can go back to the TeamViewer and say, we gave access to this number. and they hacked our computer. Can you give me some info about it? And they might help us. And another thing we can do about it is this blue arrow. I can click on it and decide what the user can do or not to do. So I can give them full access, or I can take away the access. And when they don't have an access, they can still move their mouse around the screen. But when they click on something, it just does a blob, and this gives you indications that someone wants to ask a question. So this is very good if we have, let's say, 5 people in a group, but you want only one person to control it. The other 4 can say, but what does this button do? What this button do? What this button do? So it gives you more helpful instead of trying to chase different mouse cursors around the screen. So I will just minimize this, and I will show you what we can basically see on the screen. So this is the TEM server. You're all facility managers or work in a facility, so you know the screen. The users can control this, so sometimes it's a bit terrifying. Oh, they can press the wrong button and destroy the microscope. It's hard to destroy the microscope. From this, it's easier for them just to destroy their own session, so good luck for them. And another thing we can do is the EPU screen. So we can either have EPU or tomography or EPUD. We are, in our facility, we are just Thermo Fisher based. We don't have serial EM, but if you have serial EM, you can also share that screen. And this is the screen. When you turn on EPU, this is what they see. So they can click on a button, and these are they can save the parameters they wanted. They click on a button, all the parameters they already set up before, which they know they like. Click on it, and it saves some time with the preparations. All the preparations are tabs are very accessible. I am from a very old laptop, and you can see how smooth it is working. And then you can, of course, do all the auto functions and EPU, and it. And like Becky said, we can create new sessions, and we have the multi-grid EPU session. We can do fast screening. So if I'll just create a new session and say, let's change this name, and today's date. This is a lazy grid, so I choose a lazy grid, and I click apply. I can just immediately select the squares I want to collect on. Because it's lazy, the setting up as a lazy grid is about 10 to 15 minutes, depend on how you do it. If you're doing automatically, you just basically select one grid square you like. Let's go with the grid square that has actually lace on it. Something like this, I edit, and then I can go to area selection. I already know I'm in autofocus in eccentric height, so I don't need to do it, but I can click on this button and it will let me choose it automatically. And it will take a picture. And I can add the spacing for the lacy. I remember all the parameters of the microscope. That means I'm overworking. And this will be, it takes a while because it creates spacing. So it creates spacing for all the images you see on the screen. And sometimes you can see EPU is like, I'm crashing, leave me alone. But don't touch it, it's fine. And I can remove all the holes from the outside of the grid square. And you can see here, I have broken parts of the lacy, which I don't want. So I can scroll down. And with the ice filter, the right side of the ice filter is the bright side. So I can just move it to the left, and it immediately removes things from broken parts. The left side is black. So it will unselect all these areas. So from this grid square, I have 942 exposures. Let's say I want 10,000 or something like this. I can zoom in. and select this grid square and this grid square, and you can see the number here automatically changes, because what automated system does, it applies the ice filter you wanted on the grid square it sees, and based on the gradient in the atlas magnification, it estimates how many exposures you will get from this grid square. A rule of thumb we always tell the users, if you want this, always aim higher. So if you want 10,000 movies, go for, like, say 15,000 movies, because each grid square in the end is slightly different. And I can go back to area selection. I can add the parameters I care about, like the defocus range. Don't crash, CPU. Yeah, as you can see, it's all real live. It's not recorded, so it's not responding, might crash, might not. This is a problem the users sometimes have.
Yehuda,
Yeah.
so we've had a question in the chat. So Claudia has asked, from your experience, when configuring the features that allow users to access, what is a good starting setup? Do you have any presets for minimal functionality versus full expert mode?
Yes. So in preparation, there's a lag. I can see it changing here. You can import and export parameters, presets. So if you click on import, what we did in our facility is we have CPU preferences, and we set up some initial SXML files to give you better starting points. So it's set up for a default exposure area, illuminated area, sorry, and a default basically the total dose we recommend in the facility, so about between 35 and 40. So if you don't know anything in your sample, or you're not sure what you can do, you can just take one of our presets, you can click on it, and it immediately loads these parameters. So you can see we have two of them are for hexafoils, because we found out that hexafoils are very finicky. If you don't know what a hexafoil is, it's a new type of grid from quantifoil. It's instead of squares, you have hexagons, and each hole is 0.3 microns. So they're very, very small, and they're very hard. Sometimes it's hard to work with them. So we have settings to start with these, and then you can modify it from time to time. But if we have students that basically works on the same protein with different additives, and this use always the same grid type, the same everything. So this is why we tell them, just save your own preset, and these presets can just, any user can set up their own presets, and then they can just click on it and it immediately loads the parameters for that, because I already know what I'm looking for, so I don't have to start playing around. I'm not a new user. I have the things we want. And the parameters we recommend are listed in the name of the files in the import. So they say we have two microscopes, one with an energy filter, the one we are looking at now has an energy filter. So some of the magnifications are slightly different from the one we have without an energy filter. So we have, for each microscope, 3 presets, each one with a different exposure area. And this is a good start for the exposure magnification, and this is a good starting for them. But based at the atlas magnification, they usually don't change, because it's basic. We go for the lowest magnification the microscope can do without starting to clip in the lenses. And for the heliocentric and the grid square, it depends on the type of grid. So the bigger the grid square you need, the lower the magnification you need, and vice versa. So in this case, in this grid, you can see, let's go to the right grid. You can see there is various sizes of grid squares. So the purple ones are much bigger than some of the oranges. So you have to, if you aim your grid square magnification to fit one nice grid square of the purple, you will see much more of the black in a normal grid, in a smaller grid square. So you always have this parameter to deal with. And after I, let's go back to the, does this answer your question? I cannot see the chat for some reason because I'm sharing the whole screen.
Yeah, I think that really nicely answers the question, Yuda. So essentially the canned answer is absolutely. There are simple recipes that novice users can just immediately load, but the full functionality is in the back end. So anyone in the facility can basically change any parameter that they would like to. Yuda, just in the last few minutes, I don't know if you wouldn't mind maybe sharing some of your experience running training courses. So how you run, for example, TeamViewer, and how you maybe modulate multiple users logging in from different locations, for example, and how you manage that safely.
What we, one of the parameters, one of the things we did in the facility for this workshop that we do remotely, because we have people from all over the world logging in, each one of them has to register to TeamViewer with their own university email and send us an email or a message saying, this is my name, this is my user account, I registered to TeamViewer, and then I can add him to our TeamViewer list. It's called a company. I'm not sure why, but it's basically a trusted user list that can log into the system. So I can automatically tell the TeamViewer software, if you see an access from this person, you can let him in, but immediately remove he cannot touch anything, he cannot control anything. He can log in, he can look at things, he can scratch his head and leave if he just do it remotely. And then in the morning of the workshop, each group gets to their own microscope. We give them the password of the day. We always change the password after the session. We kick out everyone in the end of the day. We change the password, and then they can log in. And because we gave them permission to log in advance, because they're part of the company, they immediately log into the company, to the right microscope, and they can do what the default for them is. So most of the time for multiple users, only the active user in that session has control on the microscope, and the rest only have the non-control, but if they click, they see we all see a bright yellow blob on the screen. So they can say in the chat, or if we're doing it on Teams or Zoom, they can say, I have a question, what does this button do? And they click on the button, it just goes blob, very white, bright blob. We can go there and say, oh, this button is the set up a multiple grid at the same time. And it's easier instead of the third button from the left, what is this doing? How we run the courses themselves, usually we are using Zoom, and we have each microscope has their own Zoom session, and each microscope has their own team viewer on the support PCs installed. On our end, I usually use the remote access, the Microsoft remote access, because it's faster than the team viewer, and I have full control all the time. And I can give them access all real time. Like you can see here, the team viewer window, I can give myself access. I can do additional options, allow control, send the chat message, close connection. I can kick them out, give control. But if I go, let me go to the team viewer window, I cannot change anything here. I see it on the lower right, but I cannot control it. So the users never know what I can do, what I can see, and also it's a private for them. I can minimize it, and then the users cannot see who else is on the computer, and they cannot get their number, so it's secure for them. They cannot just try to access their own their other computers. And then per session, we give control and take control from the other users. Becky showed the virtual keyboards before. These are the new keyboards, the control panels. If you don't have them, you need, sadly, to ask an engineer to come and install it. You cannot just download it and install it. The old keyboards, the old control panel, I think it's this one. Yep. Is this, you couldn't control a lot of the microscope. The trackball and the joystick didn't work, and everything, all the Z-axis and things like that, you have to manually write the number and to change how much the plus and minus works. While in the new ones, you can just add, like in the normal keyboard you can press the plus and minus to change if it's fine or coarse. The stage can move if you move the joystick, so you can see the red cursor here. So if I move the joystick for a bit, you can see the red cursor is actually moving. I can control the stage with it. And a nice thing they did is you have the multifunctions button. So I can align the microscope with them, because if I put the mouse on top of it and I click and I use the mouse middle button to scroll in and out, it will move the button. So I can align pivot points, I can align the beam, I can do whatever I want with it. So it's much easier for remote access. Sometimes you have a user that wants to do a session, and no one is in the facility. They can work on the microscope by themselves, and then, oh, I need someone to align the microscope. You can log in from your laptop, align the microscope, or correct things if you need to, and that's it. So this new keyboard are amazing. This is what I wanted to show you. And to ask to what Becky said, what's the fastest time you can set up an EPU session? If you ignore the alignment of the microscope, that can take between 15 minutes to an hour, depends how unalign it. To set up a EPU session with automated and lazy grids, about 10 minutes, you can do it. And then if you really want, you can just go to the session creation, not session creation, session setup, and you have this button that auto creates sessions. You just click on it. You select all the grids you want. So it only selects grids that have been atlased. So you see these two haven't been atlased yet, but you can select all the rest of your grids, and you click OK, and then you can just, it takes all the parameters you put on this session and put them there, and I will immediately have now 10 sessions that all I need to do is select square for each grid. I don't have to put the grid back in the microscope, because I can just go here, double click on this grid. It tells you there's so many things you can change because the grid is not inside. Then I just can go here, click on this grid square, remove all, select, click this grid square, and let's say I want 3 grids from each one, and that's it. That's a session. So technically it took me 10 seconds to do it. And then once I done it for all the grid squares, I can change the name if I want, because it always gives the default name of supervisor, the date, the hour, and the milliseconds or something like that. And then you can just go here, click start queue, and it will start the sessions one by one. So users can come and say, I want a small data collection, let's say 500 or 1,000 movies from each grid square. You can do it in, all my grid squares are the same. They're all lazy. They're all amazing. I click, I know which grids I want to collect from. You do it very fast and it's done. So that's to answer Becky's questions, between 10 seconds and 10 minutes. This is the fastest time you can create a session in EPU.